Hi, and welcome to our next lecture in this unit. Here we're going to be talking about two processes. They're related, but they're different. The first is weathering, and this is the breakdown of rock at or near the Earth's surface into smaller and smaller pieces. You see the results of this anytime you step outside. All those little teeny tiny rocks called soil or sand, or small rocks called gravel, that's all due to large rocks, the crustal plates, the huge bedrock of the Earth being broken down into small pieces. Now there are two different types of weathering that we're going to talk about. The first is mechanical weathering, and that is just when rocks are broken down physically, when there's no chemical change to the rock. It's not its chemical formula isn't altered at all. You could create mechanical weathering, for instance, just by smashing up a big rock with a hammer. This results in stones and pebbles and small pieces of rock, sand, silt, dust, etc. And the mix of those things, of sand, silt, dust, tiny bits of organic matter, that's soil. So this is how soil is generated. If it weren't for weathering, you would still just have giant slabs of the Earth's crust with no soil on top, thus nothing can grow, and you wouldn't have the joy of being in my class. Mechanical weathering happens mostly through frost wedging. This is a process that you've probably seen before when you've maybe left a soda can in the freezer too long and the soda can breaks in two. The same thing happens with rocks. If there's any way for water to get inside a rock, it basically will do that. And then when it gets cold enough, the water will freeze and expand, because that's one of the properties of water. It expands, it gets bigger when it freezes. And since the rock is not flexible, it can't move along with the water, it snaps. And thus a big rock will become a small rock or a small series of rocks. You've also you've seen this in the road. Whenever you pass a pothole, that pothole was probably created by a very small crack or hole in the road that water got into. And then it froze, it got bigger, and popped up more of the road loose until eventually you got a hole that might mess up your tires. This is one reason that potholes are such a big deal in northern states where it's cold, where you have this frost wedging, and not as big a deal in southern states. Mechanical weathering can also occur through root wedging, and this is when the roots of a plant grow into a rock and expand those cracks in the rocks. Plants move slowly, but they're really powerful. You've probably seen coming up through the sidewalk either the roots of trees or, on a very small scale, just some tufts of grass or something. Well, the roots of trees are big and they're obvious, and they clearly can lift up the sidewalk. But even on a small scale, the tiny little thin roots of the blade of grass are, on a microscopic level, wheedling their way into tiny little openings, or creating openings in the rock and making them bigger. So it's also creating soil out of rocks. Now there's another type of weathering that's different. It's called chemical weathering, and this is when the rock is actually chemically changed. There's got to be some kind of process here that will probably involve some caustic agent. The crystals and the minerals inside that rock are altered. It's not just that they're broken down into smaller pieces. Carbon dioxide is a very common caustic material that it's in the air. We exhale it. But when it mixes with water, it forms a very a gentle acid, at least to us. But when the acid is present over long periods of time, say on rocks, it digs into those rocks and sculpts them out. So right there in front of you, you see a kind of pockmarked rock that was pocked, not, in this case, not by carbon dioxide, but by salt. Salt is another caustic chemical. It kind of eats away at rocks over long periods of time. And so when you go to the ocean, and if you smell salt in the air, that salt, when it either mixes with water and then falls on the ground or falls on some rocks, that salt is going to eat away at the rocks like you see in front of you. That's one reason that when you take your car to the ocean, if the water near the ocean gets into the underside of the car, that's very bad for your car because it will also kind of acidically eat away at the underside of your car and mess stuff up. Your car is being chemically weathered, and that's not good for your car, so don't let that happen. Pollutants in the air can also combine with water vapor to form acid rain. The statue that you see is a European statue, and I can bet you that the stonemason who made it did not plan for it to be so kind of melted like that. But when you put gargoyles like this next to industrial areas that have a lot of factories that shoot out industrial smoke, those pollutants, once it rains on them, they get in the acid. They get in the rain and turn the rain into a kind of acid that does this over the course of years. And so, unfortunately, in industrial areas, especially in parts of Europe or in the U.S., in many of these places, the old buildings or castles or statues or gargoyles look a little bit melted. Next, this is the other main process that we're going to talk about now. If the first process is weathering, weathering is the breaking down into small pieces. Erosion is when those small pieces get carried away. So the two processes work together, but they are distinct, and you need to keep that in mind. So erosion is the movement of weathered materials, like small rocks and soil and sand, away from wherever it was they were weathered. For instance, in the picture you see in front of you, those, the sand used to be pieces of rock, and it was turned into sediment. That process, the sand used to be rock, it was turned into sediment or sand. That process is weathering. However, the waves have pulled the sand away from where it used to be, from the dunes. That's why the stairway is going off into nowhere. And that process is erosion. There are a lot of different forces on the earth that cause erosion. And they can be slow or fast, but rain, rivers, and oceans, so moving water, is very effective at carving into rocks and just carrying them away. Those small bits that they carry away are called sediment. And that's one reason that when we talk about sedimentary rock, that's rock that's been formed from tiny bits of other rock that have been moved somewhere, usually, say, the bottom of the ocean, and turned into rock there. So the eroded bits of rock move through rivers, and they're called sediment. And actually, those sediments also do a good job of kind of carving into the landscape and shaping, turning rocks in the river, say, round, because those round river rocks had tons of tiny little pieces of sand or sediment knocking against them and breaking off their jagged edges. So this kind of erosion leaves you with what you see in front of you, which is the Grand Canyon. These huge sheer cliffs going straight down to the little Colorado River at the bottom. And it took obviously millions of years for the Colorado River to carve its way and scoop out and take away all of those tiny little pieces of sediment. But nature has a lot of time. Oh, good, the Grand Canyon again. Wind is also a very powerful force for erosion. Anytime you have sand lying around or topsoil that doesn't have vegetation on it to keep it in place, wind can pick this soil up, and blow it away. That's what happened. You might remember from U.S. history class in the Dust Bowl in the American Midwest in places like Oklahoma. There had been a drought, so all of the plants died in the farms of places like Oklahoma. And then when the wind came, there was nothing to hold it in, and the wind eroded far away all the good fertile topsoil, and the people of Oklahoma had to pick up and move away, often to, say, California. What you see in front of you is called a howbob, I believe, which is another name for a sandstorm, and it looks like this little suburban cul-de-sac is about to get a pretty big dose of sand. Finally, glaciers. And glaciers are probably the most powerful erosive force on Earth because they can, it's hard for, say, a river to pick up a boulder and move it down a hill, but A glacier, all that ice, is powerful enough to move even a boulder down a mountain. It just takes time. Glaciers go slowly. They move maybe a foot or two per day, but they do flow. They flow like rivers in slow motion, down from the top of mountains, scooping out valleys, and taking that weathered material down with them all the way to the bottom of wherever they end. Whew. And that, ladies and gentlemen, is erosion.